All right, this video is going to go over the basics of solving trig. So I'm going to focus mainly on these 10 problems. I'll do these other ones in a different video. But if you don't remember, like all students take calculus, where it tells you what's positive or negative in that quadrant, or if you don't remember your unit circle, you're really going to struggle with this. So I strongly advise you go and try to remember that stuff. But let's go ahead and get started. I'm on number 1. 2 cosine plus 1 equals 0. All right. When you look at this and you see equals 0, generally that's a good thing. So like sometimes you're gonna have to factor, sometimes you're gonna have to do some other moves like this one right here, you would have to subtract cosine. It really just depends on the problem, but it being equal 0, to me, that's a good start. All right, so you would solve this just like normal. So -1, so now you got 2 cosine equals -1, then divide just like normal. So you're going to end up here at cosine x equals -1/2. All right, when this happens, you have to inverse cosine. So I'm just making some room for myself. You're going to have to cancel this cosine by inverse cosine. Which means you're really thinking, where does cosine have, first of all, a negative value, which would be quadrants 2 and 3, and what the reference angle is that throws 1/2 for the cosine, which would be pi over 3. So this one, I'd be trying to answer using my quadrant 2 and quadrant 3 angles. And the pi over 3 reference angle in quadrant 2 is 2 pi over 3. And the quadrant 3 reference angle that's over 3 would be 4 pi over 3. And those would be my answers. I hope that made sense. Let's look at another. Look at number 2. 2 sine x equals -1. 2 sine x equals -1. All right, it doesn't equal 0, but that's okay because they basically made my first solving move for me. So in this scenario, I would just be dividing by 2 next to isolate my sine. Then I would be inverse sining. And so I need to be thinking, first of all, sine is negative here. It has to be negative. So that's got to be in quadrants 3 and 4. So I'm going to have an answer in quadrant 3, and I'm going to have an answer in quadrant 4. Now the reference angle where sine throws a 1/2 would be pi over 6. And so in quadrant 3, that would be 7 pi over 6. And in quadrant 4, that would be 11 pi over 6. And those would be my answers, and I would be done. Okay, let's keep moving. If you're sitting there thinking that these are real easy, they're about to get much harder. So √3, I'm on number 3. √3 secant x minus 2 equals 0. All right, still start out the same way. So add 2. Divide by √3. All right, now here, I don't like secant. I like to change it to cosine. And then all you have to do is flip this fraction. So now it's √3 over 2. Then you hit it with your inverse cosine. And so it's positive, so it's going to be in quadrants 1 and 4. So I'm going to have an answer in quadrant 1 and in quadrant 4. And where the reference angle where cosine's throwing a √3 over 2 is pi over 6. So in quadrant 1, that's just pi over 6. And in quadrant 4, that's 11 pi over 6. And those would be my answers. Nothing to it. Okay, let's look at number 4. Tan x plus √3 equals 0. Okay, subtract √3. So you get tan equals -√3. You need to realize anytime you're dealing with tan or cotan, put it over 1. Because tan is going to be your y over your x. So when you inverse tan this, first of all, it's negative, so it's got to be in quadrants 2 and 4. So quadrant 2 and quadrant 4. And then the reference angle with a y numerator √3 and an x numerator 1 would be pi over 3. So in quadrant 2, that's 2 pi over 3. And in quadrant 4, that's 5 pi over 3. And those would be my answers. Okay. Number 5, we've got 3 secant squared x minus 1 equals 3. Okay, add 1. Divide by 3. Right here, I'm going to flip it. I don't like secant, so I'm going to change that to cosine squared, and I'm going to flip the fraction, 3/4. And so what's going to happen here is you're going to have to square root this. And when you do that, so root, when you do that, don't forget plus minus. That's super important. So this one, it's going to break down to be cosine x equals plus minus root 3 over root 4, which is 2. Now you can inverse cosine. And since I have this plus minus right here, it's going to be all 4 of these quadrants. So I'm going to have an answer in all 4 of these quadrants. So there will be one in quadrant 1, quadrant 2, quadrant 3, quadrant 4, because I'm covering both the positive and the negatives that throw a root 3 over 2. And the reference angle that throws root 3 over 2 on cosine is pi over 6. So in quadrant 1, that's pi over 6. In quadrant 2, that's 5 pi over 6. Quadrant 3, that's 7 pi over 6. Quadrant 4, that's 11 pi over 6. Those would be my answers, and I would be done. Okay. Number 6. 3 cotan squared x equals 1. All right, divide by 3. Now I'm going to root it here. When I root it, don't forget plus minus. So it's going to come down to be cotan x equals plus minus 1 over root 3. So now it's plus minus, so it's going to be all 4 quadrants. I'm going to inverse cotan. And so really, when I see cotan, I like to write x over y. So I'm looking for an x numerator of 1 and a y numerator of root 3. That's going to be pi over 3. So my reference angle is pi over 3. So in quadrant 1, it's just pi over 3. Quadrant 2, it's 2 pi over 3. Quadrant 3, it's 4 pi over 3. Quadrant 4, it's 5 pi over 3. These would be my answers, and I would be done. Okay, number 7. So I've got sine plus 1 equals 0. If they give you something that's already factored, they did you a favor, because all you'll have to do is set each factor equal to 0 and solve. So like this one, I'm going to take sine, I'm going to set it equal to 0. I'm going to take sine x plus 1 and set it equal to 0. And I'm going to solve both of these. So the one that's on the left is already good to go for inverse sine. So where sine throws a value of 0 would be at 0 and at pi. So these are 2 of my answers. And then this other one, I would keep solving it. So I would have to subtract 1. And so I'm ready to inverse sine. And so I'm kind of thinking, okay, where does sine throw a negative 1? That would be at 3 pi over 2. I still have number 6 circled. I just realized that. Sorry. That was number 7. So this would be my answer. I would have 3 of them there. Okay, number 8. It's kind of similar. They gave me something that's already factored. So I've got 3 tan squared minus 1. And I've got tan squared minus 3. Okay, it's already factored. Let's take each factor and set it equal to 0. 3 tan squared x minus 1 equals 0. And tan squared x equals, sorry, minus 3 equals 0. Okay, solve each of these. So this one on the left, I'd add 1 first. And then I would divide by 3. Then I would square root. Don't forget plus minus. It's going to be 1 over root 3 here. Then for tan, I would be inverse tanning here. I've got a plus minus, meaning it's going to be in quadrant 1, 2, 3, and 4. And for tan, I like to write y over x. So I'm looking for a y numerator of 1 and an x numerator of root 3. That would be pi over 6. So in quadrant 1, that's just pi over 6. Quadrant 2, that's 5 pi over 6. Quadrant 3, that's 7 pi over 6. Quadrant 4, that's 11 pi over 6. So those are some of my answers. And then I got to solve this other equation too. So add 3. Make it 3 over 1 since you're dealing with tan. Root it. Don't forget plus minus. So it's plus minus root 3 over 1. Inverse tan. So it's plus minus. So I'm in all 4 quadrants again. And so I'm looking for, since it's tan, I write y over x, a y numerator of root 3, x numerator of 1. Well, that's pi over 3 this time. So in quadrant 1, that's pi over 3. Quadrant 2, that's 2 pi over 3. Quadrant 3, that's 4 pi over 3. Quadrant 4, that's 5 pi over 3. All of these would be my answers. So 8 answers there. That was kind of a challenging problem. Okay, number 9. Number 9's where it starts to step it up a notch, because what's going to happen is you're going to have to make a change here. You'll see what I'm talking about. But we got sine squared equals 3 cosine squared. All right, you have to change cosine squared. So it is, if you changed it using one of those rules, it's 1 minus sine squared. All right, so from here, you're going to distribute the 3. All right, now get all your sine squareds to one side. So I'm going to add 3 sine squared. I'm going to move this guy to the left because I have like terms. So now it's 4 sine squared equals 3. Divide by 4. Root it. Don't forget plus minus. So it's root 3 over 2 because root 4 is 2. Now I'm ready to inverse sine. So it's plus minus, so I'm in all 4 quadrants. And where sine is root 3 over 2 would be pi over 3 reference. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those would all be my answers. Okay, last one, number 10. I've got 4 cosine squared minus 1 equals 0. I'm just going to do it right here. So the first thing I would do is I would treat this as a difference of squares and factor it to be 2 cosine x, 2 cosine x plus 1 times 2 cosine x minus 1. So I factored it, and this equals 0. So now I can just set each factor equal to 0 and solve each one. So 2 cosine x plus 1 equals 0, and 2 cosine x minus 1 equals 0. Okay, so on the left, I have, I would minus 1 and then divide by 2, so I'd get cosine x equals negative 1/2. And on the right, I would add 1 and divide by 2, so I'd get cosine x equals positive 1/2. So it's really like a plus minus 1/2. I'm going to have 1 in all of these quadrants because of this, but Let's go ahead and treat it separate so you can kind of see the difference. So on this left, where cosine's negative would be quadrants 2 and 3. So I'm going to have an answer in quadrant 2 and in quadrant 3. On the right, where cosine's positive is quadrants 1 and 4. All right, and where the reference angle, where I have a cosine of 1/2, that's pi over 3. So my answers here would be in quadrant 2, that's 2 pi over 3. Quadrant 3, that's 4 pi over 3. Quadrant 1, that's just pi over 3. And quadrant 4, that's 5 pi over 3. All 4 of these would be my answer, and I would be done. So if you don't know this and you don't know this, you don't stand a chance. And even if you do know that stuff, you still have to be able to solve correctly. Watch your plus minuses. Hope this video helped.